Good day, everyone. So today, my group will be presenting the first law of thermodynamics. Hi, my name is Katrina, your group leader for this day. Please allow us to present and explore the first law of thermodynamics. But before we formally started, let us know what is the meaning of thermodynamics. I know some of us do not know what thermodynamic means, so let us know what is the meaning of it by the help of our second reporter.
The thermodynamics you could tell from the root of this word. The thermo is related to thermal and it deals with the temperature. The other root word is dynamics. It deals with the properties and temperature of how do they work, how does temperature behave. So when we combine the two words, it will be thermodynamics, which means the study of heat and temperature, and how it relates to energy and work, and also how different form of energy can be transferred from one to another.
Oh, so thermodynamics is the branch of physical science that deals with the relations between heat and other forms of energy. That really connects to the first law of thermodynamics, which tells us that energy cannot be created or destroyed. It can only be converted to one form to another form. Or, the first law of thermodynamics is the exchange of energy of a system with its internal energy. Another way of explanation for you to understand. If you have a system and that system, let's say it's a gas, it is possible to change the internal energy by exchanging heat or work with the surrounding. Okay, let's suppose that we're studying the following object.
Everything else outside the system is called surroundings. So, energy can either flow into the system or flow out to the system. This flow of energy between the flow in and the flow out relationship is known as the first law of thermodynamics.
And now, let us proceed to the types of energy transfer that are possible. So, energy can able to transfer in one or two ways. We have the heat and work. To continue this, let's proceed to the reporter 3.
So here it is. There are two types of energy transfer, which is the heat and work. So first things first, we will be talking about the heat. The heat is a result of a difference in a temperature. So to make things more easier for us to understand, I'll be using this cup of water and this eraser as our example. But first of all, think of this eraser as an ice cube. So as you can see, both of them has their own heat energy, which is, for example, once you put the ice cube into the water will transfer some of its heat into the ice cube, which is, as you can see, the energy from an object has been transferred to a different object, that's what we call a heat energy transfer. So for the next, it is the work energy transfer. So work energy transfer is a result of an applied force, it can also be the measure of an energy transfer. So to make things more clear and short, for example, lifting an object and transferring it to a distance or to a certain area. So once you're done, that also means that the energy has been transferred from a different area, that's what we call the work energy transfer. So as you can see, both of them has their own differences because the heat is the transfer of thermal energy between system, while the work is the transfer of mechanical energy between two systems. So I hope you understand how the work energy and the heat energy works.
You were introduced to the concept of the first law of thermodynamics. Now, let's proceed. Let's say, for example, that we have a system, and everything outside it is a surrounding. A system is a part of the universe or an area that is under observation, while the surrounding is a part of the universe that is not included in the system. And these two are being separated by a boundary. In a system, there is already a net heat or initial energy inside, and that heat energy is what we call the enthalpy, and is denoted as capital H. It could be written in an equation as H is equal to U plus PV, where the net heat or the enthalpy of the system is equal to the sum of the internal energy, which will be discussed later on. So the sum of the internal energy and the product of the pressure and volume of the system. But that energy, which is initially inside the system, may change for the exact reason that the energy can flow in or out the system through heat and work. When heat flows in the system gains energy, and so there will be a change in energy inside the system, and that is what we call the internal energy and is denoted as capital U. Just to mention, there are three types of system. First is the open system, where there is an exchange on both energy and matter. Second is a closed system, where energy is the only thing that is being exchanged. And lastly, the isolated system, which is exchange neither energy nor matter, and said to be ideal or do not exist in the nature. But for this topic, we were more likely to use closed system. Now let's go back to internal energy. Internal energy is mathematically represented as delta U is equals to Q plus W, where delta U is the change of energy in the system that is equal to the sum of Q, or the heat energy transferred in or out the system, and W, or the work energy done on or by the system. We have processes to consider in calculating internal energy of a system. First is the endothermic process, which happens when the energy from the surrounding is being absorbed by the system and results for the energy to be positive. Second is the exothermic process, which is the opposite of the first process, where the system releases energy to the surrounding and results for the energy to be negative. To say so, whether heat energy or work energy was added to the system, if the system gains energy, then the quantity should be signed as positive. And opposite, when the system loses energy, then the sign will be negative. And be reminded that these quantities are measured by joules. For example, a 50 joule of work from the surrounding was done on the system. Then we can imply that the system gains energy. For that, 50 joules should be signed as positive. In reverse, when a 50 joule of work was done by the system and was given out to the surrounding, the system loses 50 joule and it should be signed as negative. This demonstrates the concept of the first law of thermodynamics. When energy can neither be created nor destroyed, it can simply be transferred from one place to another. Whenever a system gains energy, surrounding has to lose the energy. When the system loses energy, the surrounding gains the energy. As for the example we had, the 50 joule was not created or destroyed by the system or the surrounding. It was simply transferred from both of them.
To identify this given problem, calculate the change in internal energy of a system if 300 joules of heat energy is added to it, and if the system performs 200 joules of work. To solve this given problem, we need to use this formula. Delta U, which is represent internal energy of a system, equals Q plus W. First, we need to know if the Q is positive, heat energy is added to the system. If Q is negative, heat energy is removed from the system. In terms of work, if the W is positive, work is done on the system. If W is negative, work is done by the system.
Now, let's solve the problem. We will use the formula stated by the previous reporter, which is delta U is equals to Q plus W. First, we need to find the given problem, which is the Q is equals to 300 joules of heat energy added. So it means that the 300 joules is positive because the heat energy is added. And for W is 200 joules of work. So the work is done, which is negative. So now we can calculate the internal change energy of the system. First is delta U is equals, the Q is positive 300 plus the W is negative 200. So positive 200 plus negative 200 is equals to 100 joules. So that's the final answer.
For another problem, we have here determine the change in the internal energy of a system if 700 joules of heat energy were removed from the system and if 400 joules of work was done on the system. First, we need to find the given in the problem. So since we have the formula of delta U equals Q plus W, Q which stands for heat and W which stands for work, we need to find the heat and the work. So, our heat here is 700 joules which were removed from the system. It means it is negative. And the work of 400 joules was done on the system, which means the work was transferred on the system. So, it will remain positive.
Let us calculate the problem with U is equal to negative 700 joules plus W is equal to positive 400 joules. So, the internal energy of the system decreases by 300. So therefore, that is the answer.
Hello again, everyone. Before we end this discussion, we will give you a question and we hope to see your answers on the comment section.